Okay, guys, hello, welcome back to my YouTube channel. Good to see you again. Right now, I'm going to present to you guys about my final project. Okay, you guys wondering what is it? Let's get into the presentation, okay? Okay, so this is my final project title, which is Material and Cost Optimization for a Bicycle Frame using Finite Element Analysis and Golden Section Method. With me, Rehanan Destiawan. Okay, without further ado, let's get into the presentation, okay? So, the first thing that we need to talk about is the table of contents of this final project synopsis. The first one is the abstract and the keywords. The second one is introduction. And the third one is the objectives. The fourth one would be method and model description. And then expected result. And the last thing, of course, the references. Okay, the first one, the abstract and the keywords. Abstract. This paper aims to develop an optimal material and cost for a bicycle frame. The materials for the manufacture of the frame are aluminum 6061, titanium 6Al4V, IC1020 steel, and carbon fiber. Two methods are used for the selection of the respective materials, such as the finite element analysis method and the golden section method using OpenModelica software. The keywords of my final projects are numerical method, finite element analysis, golden section method, and bicycle frame material. So as you can see, guys, in the right side, this is the example of a bicycle frame using aluminum, titanium, steel, and carbon fiber. So maybe in the abstract, I'm not mentioning that aluminum is actually the most optimum and cost optimum, or the lowest cost that can be compared to the others. Okay, so next, introduction. The outbreak of COVID-19 causes a behavior change for humankind, especially when it comes to transportation utilization, from motor-powered transportation like cars and trains to human-powered transportation such as bicycle. The spokesperson of ITDP Indonesia, Fani Rahma, said that the number of cyclists had increased by 1,000% in Jakarta compared to the data recorded last year. This means many people will tend to buy the best bicycle quality at a reasonable price. The bicycle's invention has had an enormous effect on society, both in terms of culture and of advancing modern industrial methods. Riding a bicycle also more efficient and healthy rather than walking. The most crucial part of the bicycle is the bicycle frame. Bicycle frame manufacturers need to optimize the situation to choose suitable frame materials with the least cost possible. Analysis and simulation may be occur to help designers reduce the number of possible materials for a bicycle frame. So, as you can see, guys, in the figure 1, this is like a structure of bicycle frame. There are two main triangles, which is the first triangle contains a top tube, a seat tube, dome tube, a fork, and a head tube. And then for the second triangle, contains a seat stays, chain stays, and rear derailleur hanger. Okay. Next one, the objectives. So the objectives of these final projects are to determine the optimum quality of materials for bicycle frames, to obtain the optimal material costs for designing bicycle frames, and the last one is to implement the numerical method in mechanical engineering problems. So the next one is the methods and model description. So guys, I've said it before that we're using two different methods, which is finite element analysis and golden section method. So we're going to talk about the finite element analysis first. Using finite element analysis, we can obtain the deflection of a single truss member to force to the F with these formulas. So this is the formula of the cross-sectional area. This is area times modulus Young divided by length of the truss. And then after we get the cross-sectional area, we're going to calculate for the local stiffness matrix using this formula. And the last thing, before we're going to search for the displacement and reaction force right here, we're going to calculate the global stiffness matrix, which is we're going to add all of our local stiffness matrix to get our global stiffness matrix. Okay, the second method that we're going to do is the golden section method. In order to develop a mathematical model for the golden section method to optimize material costs, we need to define some of the equations because all of these equations are correspond to each other. And the cost formula or model for bicycle frame are Cxn equals to C times density times force divided by working stress. As you can see, here's the the properties of the formula. C is the cost material per kilogram, P is the density, L is the length of the bicycle frame, F is compressive force, and the S is the working stress. Okay, I'm using this algorithm. I'm using this methods algorithm in OpenModelica software using a C language to get the result and to get the optimization, right? Okay, the next one is the expected results. So the expected result of these final projects are the first one, aluminum 6061 T6 is the most optimal material in quality and cost rather than the other materials. And the second one is proving that finite element analysis and golden section methods are sufficient for design optimization. So this is the last thing that we're going to talk about. This is the references. There are 9 references from different journals and article. Yeah, I think that's all from you guys. Don't forget to like, comment, and subscribe. Bye bye.